In this last case, what we're looking at here are the composite functions as we looked at them before, but now these are special cases. The special case here, if you think back to the definition of the composite limits, the limit of the outer function, which would be this one, has to be defined at the limit. This function has to be defined at the limit of the inner function. So what's going to happen is you still evaluate the limit as x approaches 1 of h of x. So we're going to go here and look. The limit as x approaches 1 of h of x, okay, the limit as x approaches 1 is 2. This is 1 for x, this is 2. Okay, so far the limit, so you have g of the limit as x approaches 1 of h of x is equal to 2. Now, here's the deal. I am looking at g of 2. Okay, now this scale right here, this is 1, 2, 3, 4, 5. Your 0, this is 0 down here on the bottom. This is 0. Okay, so now what we're looking at is evaluating g of 2. But the problem here, if I'm trying to evaluate g of 2, I actually can. It's right here. So it's defined. So this is 5. So I evaluated g of 2. So that works. But what happens if the function's not defined? So here we want to evaluate the limit as x approaches 0 of g of f of x. So what I need to do first is evaluate the limit as x approaches 0 of f of x. The limit as x approaches 0 of f of x is 1. And you notice as I'm coming up on either side, these values are coming from below 1, meaning this is negative 0.999, this is 0.999, so these are all values that are below. But basically it's at 1. So we're saying that this right here is equal to 1. So then when I take a look at what's happening, this function g of x, this is where x is equal to 1. This function is not defined here. You notice you have a jump. So when that happens, you have to look at the pattern of the inside function, meaning as you approach and get the value for this limit, you need to see, are the values coming from below or are they coming from above? See how these values are above this value? As you approach from either side, the numbers are greater. Okay, meaning this right here would be like for y, 1.1, 1.2, 1.3 negatives, and then 1.2, 1.3, 1.4, and so on. So these are higher, whereas these are lower. When they are lower, you are evaluating, essentially, you are looking to see what is happening as you approach 1 from the left-hand side. So you're looking from the left here. In this case, that means this value is equal to 3. If these were higher, then you would come from this side. Okay, it's something that you have to look at. So you guys are going to do example 3.